Okay, so this is lab 7, wrapping your GA. So everybody have access to the PDF? I shown it here. So up until before the Raya break, we are actually solving the knapsack problem. We have been doing the knapsack problem for several weeks now. I hope you really understand the knapsack problem without me refreshing or recapping it again. And then this is the algorithm design. We have do the representation up until survival selection. And then last week we determine on the termination condition, that is until mass generation. Now if you test your code, it should repeat it for whatever max generation that you have set. Last time, how many max generation that you have set in your coding? How many class? 3. Yes, correct. 3. I need some response from everybody. Semua ngantuk ke? So either you type or you unmute your mic. Okay. So last time, if you run your code, you will get 3 generation. You can change that. That's later. We do it later. So for today, we want to see whether your algorithm is actually evolving or not. Okay, that's important. After you design, after you implement, it's actually time to evaluate. 2 steps. First, you evaluate your algorithm yourself, whether your algorithm is actually evolved or not. If it's not evolving, then you have to change the strategy, tuning some parameters, maybe termination condition parameters, crossover mutation probability, and so on. Second one, after you feel that your algorithm is actually evolving, then you compare it with others. Okay, so we are doing the first step now to make sure your algorithm is actually evolved. Okay, that's important. It may be because of your strategy, your algorithm is actually not evolving at all. It's just by random chance, by random luck, you get the solution. Okay. So this is what we're going to do to keep track the evolution. Okay, this one I have to give a quick lecture on this before we start our code. Okay, let's look at the slide. Okay. In just three slides, three slides on theory first. Okay, let me know if you can see my PowerPoint.
Yeah, I can see.
Okay. So for any problem in GA, there are 2 categories of problem. I highlight 2 first. Whether you're doing it in design perspective or production perspective. We have a different name for this, but use this one first. Either design perspective or production perspective. Design perspective, you want your algorithm to have a very good solution, at least one. It doesn't matter how many times you run your algorithm, but your algorithm should be able to give a very good solution, at least one. Maybe the solution, let's say if you have a fitness function from 0 to 1, 1 is the best solution. Your algorithm should be able to find a chromosome that has maybe 0.99 fitness value, or 1, the value of the fitness value is 1. That's one type of perspective. Another perspective is your algorithm should be able to find good solution at almost every run. It doesn't matter if the algorithm doesn't give you 0.9 fitness value, but if you run it repeatedly, let's say you run it 30 times, it must give you a good solution. Maybe good here, let's say the fitness value is above 0.6. So for every run, if you run it 30 times, out of 30 times, maybe 90% of the runs should be able to give you a solution that has the fitness function more than 0.6. Okay, that's two perspectives that we have here. Either you want the algorithm to give you a very good solution at least once, or you want that algorithm to find a good solution at almost every run. It doesn't matter if this production perspective give you not giving you 0.9 fitness value, that's fine, as long as it gives you consistently good solution. Okay, these two are different. Make sure you understand this. And of course, another one is academic perspective, where this is some research part on it. I don't go into detail on academic perspective. So, okay, now for knapsack problem. Knapsack problem, what do you think? Is it design perspective or production perspective? Production, any other view? Design? Okay. Knapsack problem is quite a generic problem. At our setting, where our setting last time is going to vacation kan? Going to vacation, so the items might be changed, the weight might be changed. So in that case, we want production perspective. Production perspective, because we might want to run the algorithm again with another weight, another set of item, and so on. But if we change the setting, it's still more or less a knapsack problem, but maybe for a warehouse, for example, or for another setting that really need a very good solution, that become design perspective. But at our setting, choosing items for vacationing at the seaside is production perspective. Okay, Syari, okay? Syari, can you understand? Okay. Good. Then, okay, that's the first thing that you need to know, whether your problem design perspective ke or production perspective. Okay. The second thing, your EA, your algorithm is stochastic. Stochastic means random. You never draw any conclusion from a single run, because if you notice, if you run your GA, maybe this run you will get the best solution has 0.7 fitness value. This is the first run. You run it again. You might have a different fitness value. Maybe you get 0.3. You run it again. Maybe you get 0.5. You run it again. Maybe you get 0.9. Because it involves stochastic element in the algorithm. You have a random element in the algorithm. So you cannot, based on single run, you cannot run 30 times and then you pick the run that give you the best result, or this is the performance of my algorithm. No, you need to run it several times, and you need to calculate some statistical measure on it and do some statistical test on your result. Then only we can conclude whether your EA is good or not. Okay, remember it is stochastic, and it is always about comparison. You want to compare your algorithm with other algorithm, make sure you use the same amount of resources. If algorithm A using this kind of desktop setting with this kind of CPU, this kind of RAM, make sure algorithm B also use the same amount of resources. If you use it different, it's not a fair comparison. Okay, must use the same resources, because EA is very resource consuming. And then you are using the same setting as well. Okay, that's second theory that you need to know. And the third one, okay, what are the performance index that you need to check for your algorithm? So this is four. We are going to do two of it. Best so far. Okay, let's say you run your GA 30 times. 30 times ni bukan 30 generation 30 generation. Okay, you set, let's say you set your maximum generation 15, 1, 5. So that happening in one run. Sekali run, 15 generation. Run once, 15 generation. And then you run it again, and then you run it again. So when I said run, it is not generation. Generation is inside the run. Okay, let's say we execute your algorithm 30 times. Okay, we run it 30 times. we record for each of the run, what is the best fitness? For example, run 1, what is the best fitness? Run 2, is it the best in run 2? Is better than run 1? If no, if yes, keep it. If no, means that run 1 is better. And then run 3, what is the best fitness? So at the end, how many best fitness do you will get for BSF? BSF, how many value of BSF at the end? Yes, 1. Yes, 1. You only get 1 BSF. Hold on. So you only get 1 BSF if you run it several times. Okay. And then we go on for average of current population. This one, we are looking into every run. In every run, you have several chromosomes. So what is the average fitness for that particular population? We record it. And then next run, what is the average population, average fitness for population on the second run? The third run, what is the average one? So if you run it 30 times, how many SCP that you have at the end? Yes, 30. Jensen je ke dalam kelas saya ni? Mana yang lain? 13 orang. Okay, Nabil, thank you. Okay,
30,
so
30.
Okay, so kita nak buat ni we will do in this slide, we will do BSF and ACP. Okay, I show you what we'll get at the end. Let me share it first. Can you see my Excel now? Can you see my Excel?
Yes.
Yes.
Okay, this is like just an example. I just want to show you at the end what we are looking at. So the BSF is the red line. Okay, BSF is the red line. This is the best fitness that you get for every generation. Okay, let me this one is actually just my project, so I don't document it very properly, but this is population size is 100, generation is 100, probability 0.5, mutation probability 0.15. So this is my parent selection strategy. I'm running it in laptop. So this is currently my setting. So I record from generation 1 until generation 100, what is my BSF line and my ACP line. And then I run it again. I should do it in different graph, but I just combine it just want to see the evolution. So this is my BSF. The blue one is my ACF for my second run. And this is my third run. So if I change the parameter, so let's see this parameter. This one, population size 100, generation 50, crossover probability, I tune it down and I run it in desktop. This is the graph that I get. Okay, so this is the BCF, this is the ACP. How do I get this? From the algorithm, you need to calculate the best fitness value for every generation. Iteration 1, what is the best fitness value? In this case, I didn't record it for every generation. I skip 5 because I have a very long generation. But it is good if we follow it generation by generation. So this is the best fitness value. This is the average value. So we record it and then we want to see the graph. The graph is important. Whether my algorithm is actually evolving or not. What is the performance of my best BSF and so on. Okay, up until now. Any question? Okay, Jensen, no? How about everyone else? No? Okay. So, to do that, I'm sharing my PDF now. To do that, we need to write a function to calculate the ACP. So we need a function to calculate the average fitness value And we need another function to calculate the BSF, the best fitness value. Okay, we need to function for our coding now. By the way, is my background noisy?
No.
Oh, okay. Let me just quickly shut the door first. Okay, sorry about that. So this is the pseudocode. I have illustrated the pseudocode in my PowerPoint. So this is basically what we're going to do in our lab. Okay, we have the chromosome. Each of the chromosome, we have already calculated the fitness value. Now the fitness value is only the data structure that that we're going to use today. So from the fitness value, we're going to calculate the BSF, best fitness overall, and average of every iteration or every generation. Since it's going to be data for every generation, we're going to keep it in some external file. I make the code as simple as possible, so we're just using text file for this. So after we run, this text file, best fitness and average fitness, should be able to have the data of best so far and average of current population. If you have 30 generation, then 30 value lah. So that we can plot the graph. We will plot the graph manually in Excel. If you are using other language, you might have some library for doing the graph automatically. But today we will going to plot the graph manually. Okay, and we will keep the best chromosome as well. What is the best solution at the end? Which item we will bring or we will put inside the next set. Okay. Okay, let's start with the coding. So you have this coding from previous lab. Okay. Okay, now we do it on the monitor first. Later we will I will put the coding for the file. Okay. Okay.
Okay.
For the for the declaration, we need to have the variable for the best fitness. In your next set problem, lower better ke higher better? Lower better kan? So we set this best fitness, highest possible value first. Okay. Okay, and then we have, this is BSF. Okay, this is BFS. And then we have the average as well. And then we want to keep what is the best solution. Best chromosome. So best chromosome is only one chromosome and it should have the number of gene. Okay, that's three. Okay, that's three new variable. Okay, next. We will have a new function here after copy chromosome. Let's start with BSF first. So we want to record best fitness. Okay. Let's have an empty function first. Okay, now in your GA, where should you record this? Where which line we should call the record best fitness function? After suitable selection ke? After copy chromosome ke? When? After 217 is copy chromosome. After 217, yes. Yes, as long as it's inside, as long as it's outside your generation operation and inside your generation here. But usually we record it right after we calculate the fitness value. Okay, right after we calculate the fitness value, straight away call record best fitness. Okay. So in here, we want to record the best fitness in the best fitness variable. If the fitness, okay, sorry, we need to check it for every chromosome. So for every chromosome in the population, if the fitness, if the best fitness greater than the fitness of the chromosome, then the best fitness will take the value. Okay. And then, since this fitness is the best, we want to keep the chromosome as well. So whatever index here must has the best chromosome. So we want to keep that as well. So repeat for every gene. Okay, wait, I forgot to put the open bracket here. So if best fitness more than fitness means that the one that we have in fitness is better. So we put one bracket here and we close it there. Okay, this is close for gene. This is close for if. This is close for C. Okay. Okay. For every gene, best chromosome will take the value of chromosome at index C and at index G. Okay, so what I'm doing here is check for all the chromosome. If the chromosome has a better fitness than the current best fitness right now, keep it. Okay, keep it and copy the chromosome into the best chromosome. Okay. And then, as usual, we want to see what is the output. So let's have some C out. C out. Best fitness. And then see out the best chromosome as well. Chromosome has 7 genes, so I need to copy the 4 again. But in this case, not for any operation, but just to see out. So copy the 4. Not doing the assignment on it or anything. Just to see out the best chromosome. Best chromosome. Have some space in between. And then close for the gene. Let's have some line. Okay, that is web record best fitness. I run it first. Let's see whether this code is working. Then I'll show back my code. Okay. Okay. Can you see my black screen now? Mana you? Tak nampak you sekejap.
Yes.
Okay. Okay, so we still have the get chart. Later we'll get rid of the get chart. So here population 1. Is it actually happening after ovulate chromosome? So let's see. After ovulate chromosome, this one, best fitness and best chromosome. Okay, let's get rid of the get chart first, so that we can check our output better. Chromosome, get rid of this get chart. And I want to check my record best fitness first before it get printed with other output. Get chart here should be okay. Get chart here before we enter the next generation. Okay. Okay, now after ovulate chromosome, your best fitness is 009. 009, yes, that is correct. That is the lowest one. And the best chromosome corresponding to 009 is is chromosome 2. Chromosome 2 is this. Okay, so you get the best chromosome in generation 1. And then your algorithm will proceed. It will enter generation 2 now. So in generation 2, this is your best chromosome. Apparently, it's still the same. Best fitness, so it's come from chromosome 2 as well. Okay, this is the second round, second generation, and then third generation also the same. Okay, you might get, because your population only 10, so it most probably it will be the same. Okay, that is how you record best fitness. Okay. Any question? Can you follow?
Yeah.
Okay, so where is my? Okay, that is the main code, the record best fitness. Let's see who's in. Jajin tak ada midterm ke? Ke Jajin tengah buat midterm sambil membuat lab saya? I thought all 3 BITM has midterm at the same time. Fikrun is from Indonesia, correct? Sambil-sambil, wow, Jajin hebatnya. Fikrun, okay. How are you, Fikrun? Long time no see in the virtual world. Fikrun, are you, where are you at now? Are you in the hostel? Oh, okay, you are your rental house. Okay. Hope you are doing good there, Fikrun. Okay. So everybody can follow record best fitness. Can we proceed to calculate average now?
Yes.
Okay. Okay. Run record best fitness Okay, now we have another function for calculate average fitness. Okay, calculate average fitness. Okay, we will call this function after record best fitness as well. So in this way, these three function, after you calculate the fitness value, straight away record whatever the best chromosome of it and calculate average for this generation. Okay, so calculate average fitness there. As usual, for every calculate average process, you need to have the sum. We initialize it to some value, a zero value. Then we need to look for every fitness of the chromosome. And then we accumulate all the fitness value. Okay, plus equal. That is sum equal sum plus. This is sum equal sum plus fitness. Okay, and then the sum is the average fitness. Okay, is actually the sum divide by what? Divide by what here? Average fitness. Cepat. Apa dia?
Population size.
Yes, population size. Okay, you got that. Wait, average fitness ni should happen outside the population size. Then you see out your average fitness. Okay, that's all. Okay, so basically you declare a variable. This is to accumulate all the sum. And then for every chromosome, the fitness of the chromosome is put inside the sum. After you done, accumulate all the fitness, divide it by pop size, and we print it out. Okay, let's see the result. Okay, now that is best fitness, that is the best chromosome, and that is the average fitness. So this one, this 10 fitness, we sum it up and we divide it by population size, we get 0.3. We target this, the lower the better. So in generation 2, it at least reduce. So you can roughly say that this one collectively has a lower fitness value than the generation, the first generation. And we get a lower fitness at the third generation. And we end. Okay, so that is calculate average fitness. So you have two indicator there, two index there. BSF, that is record best fitness, and calculate average fitness. Okay, did you get the same thing as my code?
Yes.
Siapa Jensen Online?
Yes.
Siapa tu?
Mervin, Doctor.
Oh, Mervin. Mervin kat hostel lagi
Ya.
Syarif pun kat hostel. You geng lah 2 orang.
Ada nampak dia masa ambil makanan.
Yep, okay. Okay, good. Haras. Aras, okay? Okay, good. Okay, now we basically done. We already get the best fitness value recorded as well as the average fitness. But as you can see, this is run several generation. So all the value need to be recorded like this Excel. Okay, it has several best fitness value and several average fitness value. So this one, if you rely on the monitor only, on the black screen only, it might not be convenient lah to record all the values. So we want to record it in file, external file. So let's do that. First, include the F stream in C. In other language, you might have another way that is more convenient, but this is C. If I do it in C sharp, I can even plot the graph automatically. I will show you that one maybe next week if I manage to have the Microsoft Visual Studio C++, I have a project that the graph is automatically plotted while running the generation. Okay, now but now we are doing the simplest one, so we include F stream. We need to have the variable for all the file. So our file is going to be output file, so I put off stream there. So we want to have 3 files, one for the best fitness. So best fitness file, average fitness file, and best chromosome file. Okay, we have 3 files here. Okay, as always with file, you need to open and close it. So let's do that first before we forgot. So we're going to open best fitness file dot open. And this is the name of your file. You can name it anything you want. I name it as best fitness dot txt. The extension can be anything as well. You can do it in Excel, you can do it in Word, and you can do it in I don't know what else the extension is. Usually Excel, Word, or text. But the most lightweight one is TextPad. So let's keep to that only. We have another 3 files, so let's open everything. So this is average fitness file. And we have best chromosome file. Open, don't forget to close it before everything ends. Close the file. Best fitness file dot close. Average fitness file and average fitness file dot close. Best chromosome file dot close. Okay, so now we're going to keep the output not only to the black monitor but also to the file as well. So basically, you just replace the cout with the name of the file. Okay, I repeat, you replace the cout with the name of the file. So I copy everything here. Now I put 2 files. Best fitness will go to best fitness file. Okay. Cout tadi tu, ni this one, cout, I change it to best fitness file. I don't want any sentence in my notepad. This is no need. I just want the best fitness. Okay. So best chromosome will cout this one. Change this one, cout ni. We don't want to publish it to screen anymore. We want to keep it in base chromosome file. Okay, so the base chromosome will have this value, and I want to have some n line in the base chromosome file so that the new one will printed at the next line. Okay. Okay, so output to file, cout ni change to the name of the file that you want the value to print it out, and don't print any sentences. We just want the value. So for calculate average fitness, are you okay with this one? Am I going too fast? Feedback?
Okay.
Oh, a little fast, Jensen.
A
Okay,
bit.
so okay. I keep it here first. 207. Open and close file. Close file. Okay. Okay. Nabil Imran, okay? If you done with the best fitness, you can do the calculate average fitness for the file. Okay, and I will start in a while. I just want to check with everybody first. Tio, okay, Tio? Tio, are you okay? Oh, Jensen, okay. Mirul ni siapa Mirul, okay, Mirul. Okay, good. Okay, that is for that is for record best fitness. So the same thing for calculate average fitness. We have only one cout there. So this is the cout for the black screen. We want now cout for the file. So the cout here we change to average fitness file. I don't want any sentence. Oh, by the way, I want it to be at the new line. So N9 lah here. Ini pun N9 lah. This one N9. Okay. Let's run and let's see if we get our text file generated from this coding. Ada error pula. Wait Base chromosome file was not declared. Base chromosome file was not declared. Saya declare sebagai. Oh, okay. Ni grup besar. Saya buat ni grup besar. So this one should be large. This is the naming constant. You usually programmer try to stick with the naming constant as much as you can. First letter, first word, small letter. Following word, capital letter. First capital letter. Yes, okay. Should be okay, I guess. Okay. Okay, it should be no change at all for your output. Let it run. Okay, and then we want to check whether the text file is generated at your root folder ni, where your root folder is, where you keep your project. Okay, where you keep your project. In this case, my project is at this path, so I should go to this path to see whether my text file is there or not. In this case, it's there. Ni average fitness, best chromosome dengan best fitness. Average fitness. Okay, 3 generation, that is the average fitness. Best chromosome, that is the one. Best fitness, best fitness saya, somehow, it get the perfect solution, which is the fitness value is 0. This means total weight equal to capacity of the bag. Okay, at the 3rd generation. So the problem is really small. You roughly can get the perfect solution if you run it several times. Okay, this is inside my IDE here, but you can check it in the, let me see, in the your Windows Explorer as well. So mine is at here. Ni, in my folder, I have the code there, and average, the 3 file is created, average fitness, best chromosome, and best fitness. So this is the average fitness. Okay, ni average fitness. Can you see my screen?
Yes.
Oh, okay. My Windows Explorer, can you see?
Yes.
Okay, good. So best chromosome, best fitness. Okay. Okay. So on the coding part, we already finished. We already get the text file and the best chromosome. Now we're going to do the graph. Before that, if you have any question, let's settle that first before we proceed to the graph generation. Any question? No? Or okay? Okay, good. Semua okay? You have 3 generations, so you should have 3 values. 3 best fitness, 3 average fitness, and 3 best chromosome. Okay, if you need more time, in settling this, I just pause the recording first, so we can settle whatever problem you have. Then we start recording again when we doing the graph. I pause it first, okay? Okay, let's increase our population so that we have a more data to play with. Okay, let's have 30 chromosome. Here, I change it here. Let's have 30 chromosome in 1 generation, and let's have 5 ke? 10 lah. 10 generation. Let's have 10 generation. Okay, that's one. And that's the second one. The first one, I increase the population size. I increase the number of generation. And then let's close all the getcha that we have. Initialize population at the getcha, we close that. This one at the getcha, we close that. This one also at the getcha, we close that. Okay. I close everything. By the way, the notepad, if you open it, you better close it to let it update. No, if you don't close it, it's okay. It will still get updated. But if you run several times, the notepad will go haywire, and I'm afraid it will not get updated. Okay. Okay, so what I did just now, I close all the getcha. I increase the population size and I increase the max generation. Let's try. So we will have 10 values now. Okay, let it run. Let your algorithm run for 10 generation. You don't have to press anything now because I already closed all the getchas. It shouldn't take long. But usually it will take a long time. Now it's only take 24 seconds. That's not long. Usually it takes maybe more than 10 minutes. It depends on your problem and your parameter setting. Okay. Okay, now we're done with this one. Let's check the average fitness. Okay, average fitness I get is like this. 10 values. Average fitness usually different value. Best fitness I get like this. From generation 10, I already get the perfect solution. So it is bring forward forward to the next generation up until generation 10. So this is considered the perfect solution already. And then the best chromosome. Okay, the best chromosome, the final solution is this one. Means that you will take item 1, item 3, 4, 5, 7, and 8 in your bag. Okay, this is the final solution. But we just want to keep track the previous solution. But the one that we will use only this one. Okay. Okay, Wong, does that answer your question? Why your 3 outputs are same? Okay, and anybody else has some question? All good? Okay, let's proceed to the graph first. If you have problem after this, I'll stop recording, then let's discuss, okay? Okay, so for the graph, I'm doing, I'm using Excel. Can you see the Excel? Okay, I'm already sharing it. Okay, so we have the generation, we have the best fitness, BSF, best fitness value so far, and we have the average population so far. Average apa? Average of current population ACP. Okay, so this is the average fitness. This is the best fitness. We're doing really manually. If you can generate it automatically, that's better. So we have 10 generation. Okay, I will copy the value from the text file that have been generated earlier. From here, average fitness is this. Best fitness is this. Okay. So I will make graph out of this data. Sekejap mana nak buat graph? So this is run 1. This one is I'm just exploring the legend here. Legend. This is best fitness. Okay, this is the graph for run 1. You can see it's, the average, the best fitness is eventually 1, mean the perfect solution, and the average one sudden drop between generation 1 to generation 2. Or this is not this is not the legend, this is paper is here. Wait, I'm just playing around with this one first to see it's working. Okay, so this is generation. So it went down up until generation 4 and goes up and down up until generation 10. So this is for the first run. And then you have to repeat this for several times. If you change the parameters, let's say you want to repeat now for 30 generation, then you will have to run it several times again and get some graph. Okay, so from here we can see it's improving, but 10 generation doesn't enough to tell whether it's evolved or not. You should need more. However, the next set problem that you done in lab is a very small problem, so maybe you cannot see the evolvement yet. We need to change the problem instances to see a better evolvement. Okay, otherwise we will get always the same value. You will get the solution very quickly and things like that. Okay, any question?
No, doctor. So far, so good.
Okay, I will end the lab now to for the recording session, and then let's have let's see your work after this. Okay, so that's the end of lab 7. That is wrapping up your GA. So basically, what we did in this lab is we calculate our performance indexes. That is best fitness, average fitness, and best chromosome. All are recorded in text file. We have 2 new functions, record best fitness function and calculate average function, where we call it from after we evaluate the chromosome, and everything is recorded in text file. Okay, everything is recorded in the text file, and then we transfer the data to an Excel to see the graph. I expect you will do more than one run to see the behavior of your algorithm. Then you can evaluate, then you can say your algorithm is evolved or not. We will explore this later in your project. Okay, that's all for lab 7. Thank you.